I'm Richard Castillo, and I'm going to be doing the test 3 extra credit for the test, of course. And right now I'm going to be doing chapter 16, question number 25. The question is asking to use the following data to calculate the KSP for each solid. It gives us the solubility. Part A gives us the solubility of CaC2O4 as 4.8 E-5 moles per liter. Alright, to find the KSP of CaC2O4, we need to use an ICE chart. So CaC2O4, double arrow, Ca2 plus C2O4 2 minus. Using the ICE chart, we can that 0, 0, plus S, so we have S here, and since all of this is going to equal 4.8 E-5 -5 molarity, KSP is equal to S times S, which is equal to S squared. So if we substitute the KSP 4.8 E-5 for the S's, for S squared, we'll get 4.8 E-5 squared, and that is equal to 2.3 E-9. Now part B is asking for the solubility of BiI3, and it's at 1.32 E-9 moles per liter. Now, same thing we have to do here for BiI3. We have to form the ICE chart. See it again. Double bond. So we have Bi3 plus, and that's plus I minus, but to balance out the equations, we multiply by a coefficient of 3. Next, we make the ICE chart. Bi3 plus and 3i still have 0. This is going to be S, and this is going to be 3s, so this will be S and then 3s. And the KSP is, since we know it's 1.32 E-9 molarity, KSP is equal to S times 3S cubed. Since 3 times 3 is 9, and then S cubed is just S cubed, times that S is going to be 27 S to the power 4. Now we're substitute 1.32 E-9 for that S. We would get KSP will be equal to 8.2 E-9. All right. Next, I will be doing question 44 on chapter 16. So question 44. For question 44, we have 3 parts, A, B, and C. So we have the question, which is asking for the KSP. So we have part A. It's asking for the KSP for lead iodide PbI2 is 1.4 E-8. We need to calculate the solubility of lead inside each of the following. Part A, we need to calculate it inside of water. So we know the KSP is at 1.4 E-8. So same here, we do an ICE chart, PbI2, double arrow, Pb2 plus I minus 2 to balance out the equation. All right, and now we continue with the ICE chart. Get rid of that, 0, 0, S, 2S. So whenever finding the KSP, it is Pb2 plus concentration of Pb2 plus concentration of I minus squared over PbI2. But since that's a solid, we can get rid of that and 1, so it's just Pb2, concentration of Pb2 plus times the concentration of I minus. So if we know the KSP is 1.4 E negative 8 as we're given, and that's equal to, so this is S and this is 2S, which should be same thing here, S 2S. Don't forget the coefficient that we have right here, squared, and that's going to be 1.4 E negative 8 is equal to 4S cubed. If we divide 4 by both sides, we will get S cubed is equal to 3.5 E negative 9. And if we cube root both sides, S is equal to 1.5 E negative 9. All right, that's the answer for part A. Next, we have part B. Part B is asking for the same thing. We need to calculate the solubility of lead iodide in each of the following. And this one, we're going to be calculating for 0.10 molarity of PbNO3 2. All right, same thing. We make the ICE chart. First, complete this. So we got double arrows, 2 plus, I minus, balance it out for 2I. And using the ICE chart, so this is like that. This is going to be 0.10 since PbNO3 is a 1-to-1 mole ratio of the Pb here. We're going to be using 0.10 as the initial concentration that we're given, and this is going to be S 0, and then this is plus 2S. Since the coefficient is 2, we get 2 S's. So this is going to be 0.10 plus S and 2S. So the KSP is equal to, same thing, PB 2 plus I minus squared. We don't need the PI squared because it's a solid and it becomes a 1. So whenever inputting this, we know that this is just 1.4 E negative 8. The KSP is just 1.4 E negative 8, and this is 0.10 plus S 2S. All right, so 1.4 E negative 8 is equal to 0.4x squared plus 4x cubed. When solved out into a calculator or using the equation, we are given, S values, not X values. S is equal to 1.8 E negative 4. And that's the solubility for 0.10 molarities of PbNO3. Next, we have to do the C part, which is going to be the same thing to calculate the solubility of lead iodide, but this time in 0.10. This time we're going to be doing it in 0.010 molarity. All right, so same thing. We have PbI2, double arrow, PB 2 plus 2I minus, ICE chart. It's going to be 0, and then this is going to go to the I because it is a 1-to-1 mole ratio. This is plus 2S plus S 0.010 plus 2S. So same thing, we know the KSP is equal to PB, the concentration of PB2 plus and the concentration of I minus squared, like the same. And with the KSP, this is supposed to be 0.010. Where does it look? 0.01. Let's just redo that. 0.010 plus 2S. KSP, we are given it, which is 0.4 E negative 8 is equal to S 0.010 plus 2S squared. After factoring all of this out, you will get 4 E negative 8 is equal to 0.0001 s plus 0.04 s squared plus 4s cubed. So after solving out for the s, we get s is equal to 1.3 e negative 4. And that is your solubility for part C, and that finishes up question number 44. Next, we're going to be doing question number 55 of chapter 16. And this question is saying that a solution is prepared by mixing 100 milliliters of 1.0 times 10 to the power of negative 2 molarity of PbNO32 and 100 milliliters of 1.0 times 10 to the power negative 3 molarity of NaF. It's asking if the PbF, which is 4 times 10 to the power negative 8, that's the KSP, it's asking if it will precipitate. So we need to write out what we have. So we know that PbNO3 to aqueous plus NaF aqueous gives us NaNO3 aqueous plus PbF2, and we are not sure if this is aqueous or solid. All right, so to find, we need to do PbF2 as a solid, find to completely ionize it, Pb2 plus aqueous plus 2F minus aqueous, and the KSP is equal to the concentration of Pb2 plus times the concentration of F minus squared. All right. So, as we know, we need to test if this is saturated, unsaturated, or supersaturated. The test letter is Q and will be compared to K. Q is always set at I, or the initial concentration. So we need to find the concentration of Pb2 plus at I, and the concentration of F minus at I as well. Don't know it. And this is after mixing. So we know that the Pb in Pb2 plus comes from PbNO3 2, and since this is a 1-to-1 mole ratio, we can use the exact same molarity and volume we're given. So we're going to be using M1V1 is equal to M2V2. M1 is 1.0 e negative 2. V1 is 100 milliliters, which is equal to M2, which is our X value or our unknown value. And that's to the total of milliliters that we're given, which is 200 milliliters. So after calculating this all out, we are given that M2 is equal to 5 e negative 4. So that's our M2 for Pb of Pb2 plus. Next, we need to calculate the concentration of F minus. No, sorry. This is the concentration of this is the concentration of Pb2 plus. Yeah, this is the concentration of Pb2 plus. Sorry, I used the calculator wrong. It's actually 5e negative 3, and that's the concentration of Pb2 plus is that. Now, so we know that the F in F minus came from the NaF. So using M1V1 as a 1-to-1 mole ratio, M2V2, we have 1.0 e negative 3, 100 milliliters, is equal to M2, which is our X or unknown, and M2 and times 200 milliliters. So after factoring all this out and solving out for M2 is equal to 5e negative 4. Oh wow, it's just what we got for this one. So but this is PB2 plus is 5e negative 3, and F minus, the concentration of F minus is going to be 5e negative 4. 1 second. So after we know that Q is just equal to the concentration of PB2 plus initial times the concentration of F minus squared initial. Since we found PB, which was 5e negative 3, and we found F minus, which is 5e negative 4. It's a horrible E. And we square that because we use the same square values. After multiplying them to each other, you will get Q is equal to 1.25 e negative 9. And since this is the Q, we know that this is the Q, and KSP is equal to, or KSP of PBF2 is equal to 4 times 10 to the power of negative 8, or 4e negative 8. So if we draw the number line, K is in the middle, like always, 4e negative 8 is in the middle, and Q will be to the left of K. K is greater than Q, which means that equilibrium will shift to the right. And so since K is greater than Q, this means that a precipitate will not form. So the PBF2 in the previous equation, if we were to go back to it. Oh, wrong way. So the PBF2 in this equation right here, the question mark we found, we don't know. We now know is an aqueous value because it is a precipitate, and it is undersaturated since Q is greater than K. K is greater than Q. And that solves the answers for question number 55. Next is question, next we're moving on to chapter 17, question number 68. All right, so so for this question, it's asking us to consider the reaction POCl3 to make PCl3 plus O2. So all three are gases. So it wants us to calculate the delta G and it gives us values in kilojoules per mole of each of them. So we have products and we have reactants. So this is actually a 3-parter question. It has A, B, and C. So we have to find products. So let's separate them a little bit more. So products, we have delta 2 delta G. Oh, sorry, I need to write up the equation. The equation is 2POCl3 gas makes 2PCl3 gas plus O2 gas. This is the equation that we'll be using for the product and reactants. So this will be 2 delta G of PCl3 and 1 delta G of O2. On the reactant side, we have 2 moles of 2 delta G F of POCl. So if we were to use the values we're given, we know that POCl3 is equal to negative 502 kilojoules per mole, and PCl3 is equal to negative 270 kilojoules per mole. So if we were to substitute PCl3, which we're given right here, it's going to be negative 270, so it's going to be 2 times negative 270 kilojoules per mole. And since this is 2 moles and this is moles, we can cancel out the moles. that. And right here, we're just going to have 1 times 0 since that's standard conditions. O2 is just 0, which would give us this as negative 540. Now we have 2 times the G of F, which we are given as negative 502 kilojoules per mole. So it will be 2 times negative 502 kilojoules per mole. Since 2 is in moles, we can cancel both moles out, giving us negative 1004 kilojoules. Both are in kilojoules. Let's write that down next. Kilojoules. We want to subtract both equations. Since these are two negatives, they'll just make a positive sign. So it's really negative 540 plus 1004 kilojoules, which will be equal to 464 kilojoules in delta G, which this value is delta G. That solves part A. Part B, it's asking us if it is standard under standard conditions at 298 K. No, it is not, because it is positive, and any positive delta G is not spontaneous but is spontaneous in the reversed reaction. Next we have part C. Oh, sorry, this is part A. Part B we answered right now. Part C. We need to find. It gives us the delta S at 179 kilojoules per mole. Delta S is equal to 179 kilojoules per mole. What? Oh, I read that wrong. And it is actually 179 joules per Kelvin times mole. Uh, 179 joules per Kelvin times mole. And this is asking of what temperature of this is at spontaneous, and we need to assume that delta H and delta S don't depend on the temperature. So when the formula is T is equal to delta H over delta S. We are given delta S, but we need to find delta H, and to find delta H, we need to use the formula delta G is equal to delta H minus delta S. We know that delta G from the past is 464 kilojoules is equal to delta H minus delta S is right here. We are given it, which is 179 joules per Kelvin times mole. And this is 200 times 298 Kelvin, which is the temperature we're given. Since this is in joules and this is in kilojoules, we need to convert 464 kilojoules into joules, which is just 464,000 joules. Let's just rewrite it. 79 joules per Kelvin times mole. I don't know why I keep reading it as kilojoules per mole. Kilojoules per mole, which is 298 times 298 Kelvin. So after we solve it all out, we are given a delta H of equal to 507,342 joules. All right. Now, if we put the delta H back into this equation, we get that on the next sheet of paper so we can see it. So the formula is T is equal to delta H over delta S. So since our delta H, we found our delta H is equal to 517,342 joules per mole. And our delta S, given in the beginning, is equal to 179 joules per Kelvin times mole. If we divide these, that's not a perfect line. You guys know what I mean. If we divide the top one, 517,342 divided by 179, we will get, since joules and moles cancel, we will get a temperature of 2,890. 2890 Kelvin, 2890 Kelvin. This is the 2890 Kelvin. Sorry, 3 times. That's crazy. This is the temp that which is a temp. This reaction is spontaneous. And that solves that. That was part C of question number 68 of chapter 17. Now we move on to the chapter 18 question, which is about galvanic cells. Let's see. So we have a chapter 18 question. So as my galvanic cells, I chose Cu2 plus aqueous plus 2E minus, which gives us Cu solid. Sorry. I just need to grab the sheet to tell me what's going on, which gives us just Cu, which is 0.34 voltage V, and the second one is going to be CO3 plus in aqueous plus E minus, which goes to CO2 plus, which is a 1.82 voltage. So drawing the actual galvanic cell, we have two of these, solution. Then we have the salt, the salt bridge right here. And we're gonna make the salt bridge, I guess, KClO3, potassium chlorate. And as we know, we have the electrodes. This is the first electrode, which is going to be the Cu electrode. And we have the second electrode, which is going to be the but it's gonna just be the, not the CO. It's gonna, since CO doesn't have an electrode, it's going to just be a regular electrode. This is going to be the CO, or sorry, it's just going to be PT. So then we have the wire connecting each of these in the box, which is the voltmeter right here. Voltmeter. These are the wires connecting each two, and since potassium will go into, right here is going to be CO3 plus and CO2 plus, and over here in the left one it's going to be Cu2 plus. The K will go into this will dissociate into this one, and the ClO3 will go into this one. After finding this out, we are given it as CuS, Cu2 plus, CO3 plus, CO2 plus, and in aqueous, and of PT. So since both are positive, we don't need to reverse any reactions. So we can just do 1.82 voltage plus 0.34 voltage, which gives you 2.16 voltage. So yeah, you have the salt bridge, the electrodes, the wires, the voltmeter, how KClO3, the salt bridge, transfers each of its respective ions into the C voltage bath and the PB voltage bath. And that is your galvanic cell. Thank you for listening. Have a good day or night.